We're going to look at the derivatives of trigonometric functions here. And we are going to start with the derivative of sine, which happens to be equal to cosine. And then the derivative of cosine is, well, if you expected it to be sine, I'm afraid you're going to be a little disappointed. It's negative sine. From these two, one could find the derivatives of the other four trigonometric functions. So just to show one of them, how would we find the derivative of tangent? Well, the derivative of tangent would be the derivative of sine over cosine. And we can apply our quotient rule. And this will give us the derivative of sine, which is cosine, times cosine. So the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator, which is negative sine, divided by the denominator square. Please note that that's how we denote the square of a trigonometric function. So in other words, instead of writing cosine of x all squared, we actually write cosine square of x. Cosine square of x. So what do we get on the top? On the top we have cosine square of x plus sine square of x, and the usual relation, which is nothing else but the Pythagorean theorem, tells us that the cosine square and sine square of the same number equals 1. So we find 1 over cosine square of x. It's fine if we leave it like that, but remember that this would be the same as 1 over cosine of x all squared. And 1 over cosine is what we have called secant. So this is secant square of x. So in other words, we now have the formula that the derivative of tangent is either 1 over cosine square of x or secant square of x. You can use either one. And we're going to use both of them, but in most cases, we're going to go with this. And now let me give the other three derivatives directly. So the derivative of cotangent is actually negative 1 over sine square of x. So please note that there is this constant game with these extra signs that appear in one of the two differentiations. So the formulas are not completely symmetric. And this can also be denoted by negative cosecant square of x. Again, recall that cosecant x is by definition 1 over sine x. The derivative of the secant itself turns out to be tangent x times secant x. And finally, the derivative of the cosecant, if you guess that there's going to be a negative sign in analogy to the other cases that we've seen before, you're absolutely right. So it's going to be negative cotangent x times cosecant x. So take a look at it. We pretty much presented 6 new formulas, right? So 1, 2, 3, 4, 5, 6. And it's these formulas we're going to play with today and try to combine them with other functions and the rules that we have seen so far. And yes, these 6 derivatives, we should know them by heart. We should be able to recall them at any given moment. And let's start with some examples where we use them along with derivatives of the other function. So for example, if somebody asks us, what is the derivative of sine x times 2 to the x? Pause your video and try to find it. And the solution will be the derivative of the first, which is cosine, times the second function, plus the first function times the derivative of the second function. And let's take now cosine x times square root of x. And again, pause the video and try to find it yourselves. And this will be minus sine x times square root of x plus cosine x times 1 over 2 square root of x. And then let's take tangent x plus 1 over cotangent x plus 2. Let's find this derivative. Again, pause the video and try to find it yourselves. And that's equal to secant square of x. The parenthesis here is redundant times cotangent x plus 2 minus tangent x plus 1 times the derivative of cotangent x. The derivative of 2 is 0. So that would be minus cosecant square of x divided by the denominator squared. So as you can see, this is the quotient rule applied to the numerator and denominator. The numerator and the denominator involve trigonometric functions, and we can apply the rules that we know. And let's also do one with secant x plus square root of x over cosecant x minus e to the x. Let's do this one. And again, let's recall our little trick with the quotient rule. Write your 4 parentheses on the top, 1 on the bottom. And what do you put on the second parenthesis on the top? You put the denominator. On the third parenthesis, you put the numerator. And then you put the denominator at the bottom. And now you need to put on the first parenthesis the derivative of the numerator. And that's tangent x times secant x plus derivative of square root of x, which is 1 over 2 square root of x, and negative cotangent x times cosecant x minus e to the x. Okay, let's try to do a couple more convoluted examples of this. So let's combine now quotient rule and product rule. So let's suppose that we have something like the derivative of 3 to the x sine x minus tangent x over 2 to the x cosine x plus secant x. Pause the video and try to find this. And here I'm going to do a very long line. And I'm going to put a long first parenthesis, a not so long second one, minus a not so long third one, and a pretty long fourth parenthesis. I hope we can fit everything, and the square. And let's put the things that we know right away. So this is going to be 2 to the x cosine x plus secant x. And this is going to be 3 to the x sine x minus tangent x. And on the first parenthesis, we have to put the product rule for 3 to the x times sine x minus the derivative of tangent x, which is secant square of x. So what is the derivative, the product rule for 3 to the x times sine x? It's going to be 3 to the x ln 3, derivative of the first, times the second, plus the first times the derivative of the second, which is cosine x. And how about the second one? Well, we have to put, let's put a product rule for the 2 to the x times cosine x. The derivative of secant x is tangent x times secant x. And now the derivative of 2 to the x is 2 to the x ln 2 times the second function. So I'm doing now the product rule for this, just this, cosine x plus 2 to the x times negative sine x. And yeah, you see sometimes with these monstrous problems, you need to play a little. And of course, I shouldn't forget to put the denominator here. And that completes our computation. Just in case this is not written clearly enough, let me just rewrite this little thing here. So this is 2 to the x times ln 2 times cosine x plus 2 to the x times the derivative of cosine, which is negative sine x. And that's it. Okay, you can try to put your own combinations of such functions on the numerator and denominator, and do as many examples as you can to get used to these new 6 formulas that we presented today. Thanks for watching.